right. Our next speaker is Steffen. He is a researcher in Kyoto University, specializing in mathematical biology. However, he's going to present us something very different. So this session is actually about the music. So he will give us a live coding performance using Julia.
If it works. Okay. So, okay, can everyone hear me? Yes. Yeah, so I will present something which is not my research, but something I do on the weekend or in the evening. And who was there yesterday evening? Okay, that's not good news for me because I cannot beat that guy. But we are still having some fun here with Julia. That's. It's in Julia, yes. So I have a few disclaimers. So I'm not a musician. I'm really not a musician. I'm really not a musician. I'm just a programmer, okay? Just that you know. So all of this here is about experimenting with the Julia tools and what we can do. And I will just steal from people who do this much better. For example, for me, the story started that like 4 years ago during Corona times, I was locked down in my home. And one thing I started is learning Julia, and the other thing which I started was falling in love with live music in the style how you have seen it yesterday. For example, how Andrew Sorenson is doing it. And an interesting thing is that these tools, they actually require similar conditions than Julia. So Extempore, for example, is a programming language which is inspired by Lisp, but it has a just-in-time compiler and is able to do digital signal processing. So it's actually a language which, in a sense, is attempting to solve the two-language problem as well for that particular domain. And there are a lot of frameworks out there. We have seen yesterday one of those frameworks which attempt to make musicians able to use code to generate music. So I'm not going to compare it, and the goal of this is not to compete with these frameworks. The goal is here to have fun with Julia. So we can do it in Julia, and I don't know why, but let's try. Now comes the part which is very scary. Seeing if everything works. So the one part of live coding which is cool is that we can build up the music step by step. So I have somewhere here the script which I want to hopefully perform here, but our goal is to do it together in a little bit, and let's see if I can play a note. So later I will also explain a little bit how all of this works. Shall I zoom in? Yes. You don't need much of the terminal anyway. Here. So play note is a function which is calling port MIDI, and it's a small C library. We give notes like yesterday as numbers, and 60 is, for example, the C4 note. Then we can give a velocity, let's say 120, and the duration of the note. Yes, it works. So here we can hear the sound. And okay, that sound is not planned, but let's hope it goes away. So okay, now basically we can play around with this. And one interesting thing is now we can put it into a loop. But putting it in a loop, how we have seen yesterday, is a little bit boring because the loop plays once and we cannot change it. What is more interesting is, for example, the concept of temporal recursion. So I could call a function, which I call something. It doesn't really matter here. And here I could say, okay, let's play my note. And for the moment, we don't care so much about global variables, okay? So let's say this. And then we say, let's sleep for a certain duration. Let's say 1 second. And then we could call this function again, like this. I need to call the function. Okay, but now what I want to do is I want to change the function while it's running. So does someone know how to do that in Julia? What do I? Closures. Okay, I don't know if I can do it with closures. But some other suggestions? Exactly. So if I, like, while the first thing is I don't want to block my session, so I could call this here with async. And then if I put here invoke latest in front, so that's in base, but late, is that correct? Okay, that is correct. So now I can do things like okay, so this is actually how Andrew Stevenson is creating all his music by making these temporal recursion loops. But of course, we can also just make a for loop which calls with base invokers. So I have implemented that as something I call mRepeat. So this has the metronome and it eats a function. So it's a simple for loop which just calls this. And in this way, I can basically work a little bit nicer with this. So now what I'm going to do, I want to play a small melody. And this mRepeat, it assumes that I return true and some inputs like this. Let's say this is a counter and my instrument is the piano, so I get rid of this really bad global state. So now yeah. So now I can play around with this thing. And one note is one thing, but we want to maybe play a melody. So this is now a function which just eats like a few notes, and I can give some rhythm to it. Let's say just duration and some velocity. Let's say we want to randomize the velocities. So I want to have values between 40 and 80 and 4 of them. And duration is, let's say, 1 beat. So I'm now replacing that. Now we have a little bit of a melody. And for this melody, maybe we want to make it more interesting and add like something like a root note. So here I'm now copying actually a performance by Andrew Stevenson, but it's much more entertaining to have good music instead of my crappy music. So what I'm doing here now is, let's say we have a reference in a global state, which is some, I don't know, some note. I memorized the modes. So root is my reference, and now I want to play, oops, I want to do this, and everyone who knows Julia can read it. So now we have put the last two together, and we go always back to the root. And now we can do the following. These inputs are going to be the inputs for the next call of the function. So what I can do now is that I change my root node every few steps. So let's say every 2 steps I say the root is a random element, and let's say I have 50, 52, 48. And I want to take these nodes, but I want to remove basically the current root node. Is not the current root. Let's see if this works. What did I do wrong?
The function is root equals root, not root equals root index. In line 15.
Line 15.
I think root equals root.
Ah, yes. Thanks. You are much better live coders than me. Thank you. So now we have a little bit of some music which is moving around. And okay, let me copy the next hand maybe, because I think it's going to be more entertaining if I don't make so many mistakes because of being nervous. When we are now generating music, we can do a lot more things. For example, we can introduce scales. Scales are basically notes like the C major scale or something like that. And here what this nice function here is doing is that when E is increasing, we sample a few time points, and then we can put these time points into a cosine function. And we can modulate with a lot of, with different frequencies. And by using this trick, we can generate basically a melody which is like going up and down a little bit unpredictably, and then we quantize it to the scale. And if I'm adding this, we can generate basically a little bit of beautiful music with a small Julia program. And all of this can go much further, so I'm just adding a little bit of drums. These are just like the MIDI notes which perform certain drums. And because of InvokeLightus, we can also now change something in these functions all the time. So if I want to, I don't know, put these notes a little bit lower, I can change it while the music is playing. And this is the art of live coding. So you can now experiment with the program and try something crazy. I'm too scared of doing that, to be honest, right now. So I will just copy one more line from here, which should introduce a nice bass to it. And then when you perform it in the end, you maybe want to pull out these elements. So one way to do that is to make everything a bit more silent. Oh, I'm really nervous. Well, I'm usually not a nervous guy, but yeah. So let's stop it here. So this is what I wanted to show you, and now I want to present a little bit how all of this is working. So let's go back to the slides. So actually, there's not so much going on here because all we need to do is to send out MIDI notes. And how this is working is I used CLang, which is a classical tool to wrap a C library, and created this port MIDI library, which allows you to send and receive MIDI notes. And the only new part, so to say, is that I can now write this function PM write short is the function from port MIDI. And with this function, I can send a note on and note out of message. So you can see this is allowing me to play a note. And then there's a little bit of code to load basically the MIDI channel and all of this, but this is very uninteresting. If people are interested in using port MIDI, then we can, of course, make a nice Julia wrapper around of it, but I didn't feel like the right person to suggest how to make a MIDI library. But please chat with me if you want to use MIDI in Julia. And the setup is very simple. So if you want to replicate it, you need a Julia session which sends out MIDI notes. Then you need to create a MIDI channel on your computer. So Loop MIDI is, for example, on Windows the solution for that, and there are built-ins on the other operating systems. And finally, you need something to generate the notes, which is here with sound generating. I'm just using a computer program. So just showing it here, I have Loop MIDI, which receives the notes, and then I have this computer program, which has some tools basically to make the piano sound. So in this sense, there are also free alternatives. So for example, if you don't want to spend money, I can recommend a program called VCV-Rec, where you can do quite a lot of things. And now a little bit about the Julia for the timing. So doing the timing right in these kind of things is very challenging because your program is running and you're maybe interrupted by just-in-time compilation. So the game is somehow we have these notes which my program should spill out. And how do we do it? So the beginning of, let's say, we are focusing on one bar. One approach, how I solved it, probably not the best, is we can use the async function to basically execute something and directly continue the logic of our node generation. So, for example, I can use async, begin, blah, 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 to play the notes, and I can sleep in between notes. So, for example, if I want to play these two notes, I can say play note, sleep for 2 beats, and play another note. And this would then be a function where the execution takes, like, for example, this long. And there's a little bit space left back here, and this space here we can use to compile with invoke latest, maybe the function which has changed during the execution time. And one important thing is now for the implementation, if we use invoke latest and directly continue with play note in the function, then actually it will there will be a delay. So the smart strategy is that my function, which is spilling out the notes, has in the beginning a sleep, which expects that it's a little bit ahead of time, and then it sleeps just until the moment when it should play the note. And because all of this is inside the function, I can compile it, start the function ahead of time, and then play the notes. But there are much smarter strategies out there to do that. And yeah, the worst thing which could happen is that for some reason this function takes too long, and then we could get into the situation, like when the compilation takes too long, we could get into the situation that we skip over an entire beat. But at least we only hear no music for 1 beat, and then we are again in sync. So this is how I used it in this example. And now this presentation, I tried to make it short because I think it's maybe interesting to chat about what one could use with this tool. I made actually 2 other demonstrations. Maybe I can ask, who wants to hear generated drums and who wants to hear some ambient music? So who wants to hear drums? Okay, and who wants to hear ambient music? Okay, ambient music. So I will load the second session here. So now here what I prepared, and this time I'm sorry, I will just pull out the code and show it to you. So here, if I can talk a little bit more about this init session. This init session is really just a 100-line Julia file which doesn't do a lot of things. But the metronome is basically only something where I save how many beats do I want to have per minute. An instrument couples the MIDI stream, the channel, and the metronome, so that whenever I pass the instrument somewhere, it has all the information I need to play in tune. And now here with this chords function, what we can do, for example, is that we can generate random chords. So here I just have a few offsets, and I can take a random variation of these offsets, add it to my root, and maybe my root I can change it every few bars how we did it before, and then quantize it. So if I'm doing this, do we get something? So this is silent. Sorry, I need to restart the session. And here with the lead, I just used a small offset and I randomize every few iterations basically the how high these notes are. This is a bit loud. And then I created some drum pattern on top of it. Yeah, when I started learning Julia and making music with it, my goal was to generate such music and then just code a little bit more Julia endlessly. Yeah, and I think maybe that's a good point to stop here with that demonstration. I have a few more outlooks. Basically, I just talked with George Datsiris from the Agent JL, and he is a drummer, and I think he is quite famous for his talk he gave on drumming. And I just figured out that you can also use his package on generating motifs and hook it up with this port MIDI to use his crazy motifs he generated and play it through port MIDI. So I just copied from his webpage some crazy thing. I can quickly show you that. I need to stop these loops. So this is now a motif generated by the package music manipulations, which allows you to generate random note sequences. And I did the mistake again. Yeah, and with this I will then basically end my talk. The next steps could be, who wants to use that? Shall we make a proper package out of this? There are things which one can do, like, for example, generating actually sound with port audio and doing proper timing. And finally, one can integrate these things with musiccoe.jl or music manipulations, for example. And this is the drum pattern that was generated by music manipulations running through port MIDI. And with this, I want to close the talk and thank you all for coming and motivating me.
Do we have any questions?
Hi. I liked your talk a lot, and I have a question. Maybe I missed it. Do you have any string instruments currently programmed in your code?
So this code is only sending out MIDI notes. So the program receiving the notes could have string instruments. Yeah.
Okay.
So.
But you haven't played around with them yet?
No.
Okay.
Actually, I thought I have much more time to prepare, and I didn't.
So also answer to at least one of your questions, yes, please make it into a package.
Thanks.
Yes, I agree.
Yeah, really cool. I've also played around with music generation that was, although not in Julia, like years ago. And I always disliked that things were so in time usually, because, I mean, right, you do 16ths, you do whatever. And have you ever thought about adding some like humanizing algorithms to this, so that your whole time base basically wanders around some tempo and it is not so static, right?
So I didn't, but George did. So he has the humanize function.
Oh.
And yeah, that works. So all I needed to do is to write this like 5 lines of codes to play the notes according to his setup, and yeah.
So I guess that's for like a given number of notes, right? And then it shifts those around, right?
So you can also humanize in these demonstrations quite easily, because so here's the duration of the notes, and these are vectors, so I can just add random elements to it.
Yeah,
So
I was thinking basically
that works
doing
on the
this
fly.
while your metronome is running, and then I assume there's some, or is it just a sleep, right? But
Yeah,
maybe like random, putting like a small random on the sleep, right? So that
that would directly work. So here, in this duration of the notes, or no, here, one of these inputs, I think this one is the duration of the rhythm when the notes start, and this you can randomize however you like.
I don't have a question, but I have a comment. This is really cool. Thank you. This is great. Forget making a package. I want to put it in bass.
Yeah, it's only 120 lines. Thank you so much.
But yeah, actually, I think, but seriously, I think we should use this as an example in the manual for at async. I think that would be really cool.
Oh, wow. Thank you.
So two questions. Number one, is the fact that Julia's sleep only has millisecond resolution a impediment here? And can you say the sentence, Jameson, I need sleep to have microsecond resolution for me, so that I can convince him to do that?
Is it a tongue twister?
Um,
So, okay, to answer your question, actually, the proper way to implement it is that port MIDI is a C library which has a threading like based synchronization. So you have you have an input there to give a very precise offset to your notes. That would probably be how one should solve this. And I don't know if I need a better timer, but I'm sure we need a better timer.
Thank you.
Yes, so I have a question. So now you're doing MIDI output. Have you tried playing around with MIDI input as well to sort of be able to manipulate it using external controllers?
I
and
haven't
stuff?
played around with it. There's a C function callback, so it should work, but I didn't try yet.
Thanks for the demo. Once again, love these live music coding. I'm not necessarily having a question, but I do think there is a big gap where you can really make a lot of musicians, professional musicians who know scales and stuff, happy. We have, there's this thing called a looping station which does take MIDI input and then like place it back in a loop, and you can use these pedals to do it. And at the moment, these are proprietary devices. So it would be amazing if you could code something like that, which takes the MIDI input and uses all this threading in Julia. You can make it open source. You can make somebody the budding musicians can use their laptop to make amazing music with this. So I think as an open source language, this would be a very nice project for anybody who is into these things.
Thank you, Jilak. I think one cool thing in general would also be there's a new plugin format called Clap, which is quite friendly, and like basically merging Clap with a Julia, like something which can call Julia code for digital signal processing could be quite fun in that area. So I agree, but it's a lot of work to make these things.
Obviously, I'm just throwing it out there.
I suppose this is a bit less about your what you're working on and more about that music manipulations package and that humanize function. So while we were looking, I was looking at the source real quick, and I noticed that it seems to use it adds noise, but it doesn't seem like any of the noise algorithms that are currently available to it are kind of continuous-ish. So I've heard in the past, and it makes sense to me that it would probably be most productive to add like some kind of fractal noise to it. In the past, I was working on a fractal noise package for fun, but I never published it because I never finished it because I didn't have a use case. But I just searched up, and it seems like other people have made some really competent fractal noise and also like similar like continuous noise packages that are way more competent than anything I could ever do, of course. But I guess what I'm suggesting is, maybe talk to the person who's working on music manipulations and see if they can hook up that humanize function to one of the many fractal noise libraries we have in Julia now.
Okay, cool. We can see what happens. I will chat with him.
I think we have time for one last question.
Yeah, love this. This is great. Yeah, my question was, it seems like for live coding, Julia's syntax is getting in the way in a lot of cases. Have you thought about creating a macro to make some of these constructs easy to write?
Yeah, actually I started with macros and then I turned back to functions because one thing which I like about this Julia code, I don't know how you felt about it, maybe it's a bit fast, but it's relatively readable. So you can look, for example, at this definition of the left-hand side here. It's like quantized melody, whereas the where I stole it from, basically the Lisp is, it's a bit harder to read, at least to my eye. There are some people who will disagree. Yeah, but you can definitely make a lot of macros and super cool specific quick language for that.
Yeah, of course.
Yeah.
I mean, this is great to read. It's just that if you're live coding,
Yeah,
the
you
least
miss a
number of
bracket and then-
characters is important.
Yeah.
Yeah, anyway.
Yeah, definitely.
Thank you.
So thank you very much, Steffen. Another round of applause, please. Yes.